Welcome to my video report on the graphics of my racing game project. As you can see, the sky box is quite beautiful. It's a night sky with a nice moon, as well as the darkness being rendered onto the grass itself, and every object within it. The vehicle is textured very nicely with all of the UVs set up properly, as well as the track also has a texture denoting where you can go. The track itself is a separate model. Moving to a lighting demonstration. As you can see, these cubes are point lights, and so they make a use of all ambient, diffuse, and specular lighting. The diffuse lighting will shine brightest on the surface that it hits first, while ambient lights surrounding surfaces. The lights also have a radius, so this green light emitting over here can also be seen on this side here. Lights can also combine colors, so this red and blue color combines to be purple. This also affects the vehicle as this side is much brighter with a slight purple tinge, while this side, which is facing away from the moon, is much darker. There are two directional lights, one from the darkness of the sky pointing onto the ground, and the moon shining white, which can be seen here. Finally, of note, there is a flashlight sort of effect, a spotlight, which can be seen by this very bright circle. Now moving on to how I have implemented all of these lights. The first thing I needed to add to my scene was ambient lighting, which simulates the fact that light bounces off of multiple objects within the scene, and so indirectly illuminates other objects, such as this cube. But the strength of the light should be much weaker to represent that. Next up was diffuse lighting, which takes into account the direction of the light source compared to the face of the object. If the face is pointing towards light source, it'll be much brighter than the ones pointing away. And finally, specular, which is pretty much how much an object shines and reflects. This image here showcases all three lighting being implemented, ambient, diffuse, and specular. To calculate this, you take the direction of the light source and you get the reflection direction of that, and you compare that against the viewing direction where you are in the world, as the shininess spot will change depending on where you are looking, and so it will move around. It also takes into account the shininess value of the material as well, and if this value is 0, then the faces will be as bright as the bright spot, as you can see now, with a higher shininess value making the bright spot much more focused to a single point. Other formulas that affect this, the attenuation is how a light source gets dimmer over distance, and this can be manipulated using two values, a linear and a quadratic value, which simply just changes the rate at which the luminosity declines over time. Light formula below decides which vertices should be illuminated by the light source, and so changes its intensity accordingly. In conclusion, I would say that the light source that I've made illuminates the scene very well. The skybox is seamless and vastly improves the scene. It looks very nice, and the fact that the directional lighting also affects the entire world makes it dark and also pronounces the other light sources very well. However, I'm using directional lights to simulate the skybox itself rather than using the skybox texture, which would also show the clouds onto the grass field, which would look much nicer. Also, currently lights can pass through objects and can illuminate other objects behind them if their range is large enough. You can sort of fix this by lowering the range, but that is not a viable solution, not a good solution.